Hello, everyone. Last week, we learned what a categorical proposition is and how to visualize categorical propositions in pictures called Venn diagrams. This week, we will need the technique for the purpose of evaluating arguments called categorical syllogisms. So let's first look at what a categorical syllogism is. What is a categorical syllogism? Categorical syllogism is an argument with two premises and a conclusion. And that is a syllogism. A categorical syllogism is nothing but a syllogism with categorical propositions as premises and the conclusion. So for example, this is an example of categorical syllogism. There are two premises, first and second premises, and there is the conclusion. So two premises and a conclusion, and all of which are categorical propositions. As you can see, this is categorical proposition called what? A-type, right? The second premise is categorical proposition again. It's E-type. Finally, the conclusion is a categorical proposition of what type? It's type I. So, categorical propositions, categorical syllogisms are arguments like this. And in this chapter, we will learn a Venn diagram technique of determining the validity of categorical syllogisms in general. We will skip first a few sections in this chapter and go directly to Venn diagrams section. And we will also skip everything after that. So that means we will just focus on one section in this chapter, Venn diagrams section. All you have to do in this chapter is to learn how to use Venn diagrams to determine the validity of categorical syllogisms. This is the main thing in this chapter. And it's not really complicated. You only have to follow a few steps, and I will explain that. So determining the validity of a categorical syllogism, and we want to answer the question, which categorical syllogism is valid and which is not valid. And we like to use the Venn diagram method to determine which is which. So how do we proceed? First, draw three circles that represent the three categories in the original argument. I think it's useful to talk about an example. Okay, so let me talk about. Let me write down an example here. So let's say. So here is a categorical syllogism. It's an example in the book. No, the first premise is no M is P. The second premise, some M are S. And the conclusion is some S are not P. Now the first step says what? Draw 3 circles that represent the 3 categories in the original argument, SPM. Okay, so there are 3 categories, M, P, S. So you draw 3 circles that represent these 3 categories, like this. 1, 2, 3. Okay? And you have to specify which circle represent what category. Okay, this one represent, let's say S, and this circle represent P, and this one represents M. Okay, so to do that is the first step. Second step says, draw 2 premises in the diagram one by one. And when you do that, a very important restriction proviso is that when 2 premises consist of a universal statement, meaning a categorical proposition starting with the quantifier all or no. Okay? Universal statement and an existential statement, a statement starting with the quantifier some. So when 2 premises consist of 1 universal and 1 existential, draw the universal statement first. That's very important restriction that you have to keep in mind. So keeping that in mind, let's complete the second step here. So here is the first premise and second premise. And this is a case of that, right? 2 premises, one is universal and the other is existential. And the rule says, draw the universal statement first. Now in this case, the universal statement comes first, so automatically it goes first. But even if this comes first, you have to diagram the universal statement first, okay? Regardless of the order in which these premises are presented. You have to draw the universal premise first into the diagram. Now, let's draw then this first premise into the diagram. The first statement talks about a relationship between M and P. M and P. So, you ignore S circle for a while. Just focus on M and P. Okay? So how do we draw no M is P in the diagram? Now last week we already learned how to do that. Okay? We shade the area in between. Okay? This area is eliminated. No M is P. Okay? There is no overlap between M and P. So we eliminate area, overlapping area. Okay? Okay. How about the second premise? Some S are P. It talks about relationship between M and S. So you ignore this time the circle P and just focus on S and M. Some S are P, some M are S means that there is something in common, M and S, right? So you draw X mark where? Somewhere here, right? You have to draw X mark somewhere in this area. But notice that area is divided into 2 parts, and 1/2 of that is already eliminated. So there is only one area left, and you draw X mark there. Okay? You draw X mark there. Does it make sense? you have to draw X mark. Some MRS means you have to draw X mark somewhere here. But then because of the first premise, half of that is already gone. So you can only draw X mark in the remaining area. That's what you do. Okay? Put X mark there. Now once you, okay, that's the that's second step. Okay? So we have just completed the second step. Where is the third step? Let's go to third step. Third, after you draw two premises, in the diagram, you try to see if the conclusion information is already there in the diagram. Now, what does that mean? Well, let's go back to the example. Now, you draw these two premises into the diagram. That's what you did. And then you look at the picture and try to see if the conclusion information is already embedded in the picture. Okay? Some S are not P. So it talks about the relationship between S and P. So forget about M. Do you read some S are not P in the diagram? Is that information already in the picture? Yes, it is. Okay? Because there is something inside of S which is outside of P. There is X mark there. So this conclusion information is already embedded in this diagram. So you can read the conclusion from the diagram back. Okay? And when that happens, okay, it says what? It says if the conclusion is embedded in the diagram, then the argument is valid. So the example you just saw is a valid argument. Okay? Otherwise, it's invalid. This argument is valid. That means if these two premises are true, the conclusion must be true. In other words, the conclusion follows logically from these two premises. And you have just shown that that is the case by using the technique called Venn diagram technique. Okay? There is one thing that needs to be explained. Let's go back one step. It says when you have to put X in an area which is divided into two, and there is no information that rules out one part or the other, then put X on the borderline. Let me explain this by using a different example. Okay? Let me see. Let me erase this. Okay. Here is another example. Or PRM. Some S are M. The conclusion is some S are P. Okay. You draw three circles. Okay. Let's say this is P. That circle is for S. And this circle is for M. This is again on a case where you have universal and existential premises. So we draw the universal premise first, or PRM. So we look at these two. or PRM. That means we have to shade out or PRM. Okay, we have to shade out this part. All right. Or PRM. So there is nothing inside of P and outside of P. Now what that means is everything inside of P is now inside of M. So or PRM. Second premise says some S are M. Okay. So some S are M. That means there got to be X mark somewhere inside in this area, right? There must be X mark in this area. Notice that this area is divided into two parts, and we don't know where X should go. We are not given any information about which of these two parts X must be put in. We don't know yet. So in that case, you put X mark on the borderline. So you put X mark there. Okay? What this X mark on the line means is that X is indeterminate. X can go either one of those two areas. And we are not given any information about which area X should be. But what we know for sure is that X must be somewhere in the big circle here. And that's all the information we know. And that's all we need to do. Okay? So that was the tricky part. And other than that, I think everything is pretty much straightforward. So you go back to the textbook and you have to do practice quizzes yourself, okay, to learn to master this technique. Okay, that's it for today.